Hello everyone, welcome to Pisa Presents with Zircons, both gemstone and geologic clock. So let's continue. Now first of all, zircons are both a mineral and actually a group of minerals. They're very common. They're common in not only igneous, sedimentary, and metamorphic rock, but they're also found in meteorites. Now some local at least to the club, localities include the Buckwheat Pit of Franklin, New Jersey, and Danbury, Connecticut. So if you're in the area of either one of those respective mineral clubs, they're great people, so go ahead and join. Now, the overall formula of a zircon is this right here. But keep in mind, the M can stand for several different things. Altogether, most commonly, the first out of the list. Now, speaking of lists, there are not one, not two, but 6 different zircon minerals. The most common one altogether is zircon, the last one right there. Now, something that they all have in common is that they're in the tetragonal crystal system. Elsewise, things can kind of vary. You see that the specific gravity there goes from about 4.6 to just under 7, and their hardness ranges from 4 to 7.5. Now, if you look at the formula up there, what do those formulas have in common in terms of, say, outside elements? Well, zircons have quite a few different interesting things that you can find in them. Say hafnium, uranium, few other things. Now, a lot of these elements you may have already noticed are actually radioactive, which is very, very important for the future. We'll get into that extremely shortly. Now, altogether, henceforth, we're going to be talking about just zircon itself, the mineral. Now, zircon is a very famous gemstone, of course. As a gemstone, zircons are really used to both that. There are some industrial applications like, say, ceramics right now, but altogether you're looking at geochronology, and as a gemstone are its 2 most major uses. It's actually one of the birthstones for December. So, happy birthday to everyone born in this month. Now, this right here is a pearl and zircon ornament. Now, zircons as a gemstone are a very, very varied ball of wax right here. They go by various trade names depending on the color. Down below, and then I'll link to it in the description, is an absolutely wonderful site that goes into a lot of just some of the little ups and downs of using zircon as a gemstone, and also the various trade names respective to each color. Now, altogether, the most common one is brown. You can alter this to blue or colorless via superheating. A very high proportion, it's thought, of that very, very pretty, the cerulean color blue right there, zircons, are via superheating. It's not the type of color that you commonly find a lot in nature. Green is often found not really found in nature often. It's very rare, but still, green is found in nature as like a khaki sort of color. Now, pinks, reds, and purples, if you find those are often the result of millions of years of just age and great heat combined all together. Just to give you an idea, if you find a zircon of that color, it's the result of a lot of work. Now, this is a zircon cluster here. Blue zircons are often called starlight or stremlite, and again, keep in mind, this is often something that's the result of superheating. I can tell you right there, a color that deep of a hue of blue, that is definitely the result of superheating. Now, said before, most natural green zircons are a khaki color, and a trade name for those is beccarite. Still very, very pretty. Trade names for deep yellow zircon, they vary depending on whether or not it's a pale yellow or really a deep yellow. So deep yellow is chrysos, and also for pale yellow, jargoon or jargon. Some people say that the latter 2 names are rather out of date, but I still see those used a lot in certain some websites trying to sell people jewelry and other things. So just so you know if you see it. Hyacinth or jacinth, or some people say jacinth, are trade names for red zircons. Now, maybe wondering, cubic zirconia is actually not a zircon. It's an isometric crystal, most likely lab created. Formula is ZrO2. So why do you do the substitute? Well, zircons do make passable diamond-like gems, and obviously they're very beautiful, but also they're very brittle. Like zircon is not a common choice for, I'll just say, an engagement ring stone, because if you think about how the ring is faceted and then held to the ring, a lot of the edges of the actual gem itself are often exposed. And because it's naturally a very brittle stone, it's just not the type of thing that you see in a setting like an engagement ring unless it's enclosed all the way around. Like a lot of zircons in earrings for the same reason, because you don't typically have an earring all the way enclosed and it's just sort of kind of dangly just to be pretty. And a lot of them are lab created. So while zircons and zirconia make passable diamond-like gems, zirconia is really famous for being that diamond substitute because they're not as brittle as zircons are. Now, this is a very, very beautiful zircon right here from Finland. Nice, deep, dark color. And metamictic is a word that you'll see a lot in the literature. So what does that mean? Well, are minerals with radioactive impurities, our friends the zircons. Now, that radiation, while, first of all, be perfectly clear, there is not a danger in you wearing zircons if you have zircon jewelry. Keep enjoying it. I'm sure you look great in it. It's lots of things have very, very small amounts of radiation and are perfectly safe for you to be around, one of which are zircons. But still, over time, and this is great time, keep in mind, over Great Lakes and time, the alpha radiation emitted from said impurities do manage to degrade the mineral internally. Now, this takes a very, very long time, but in zircons, over together, people see it lowering hardness, refractive ability, and specific gravity. And also sometimes it can alter the color a little bit too, with them changing to sort of like a dull, like a matte black, a brown, or a green. Now on to geochronology, or radiometric dating. No, not that other kind of dating. So radiometric dating involves isotopes, which are, now this carbon-14 is not involved with zircons and dating, but as it's the one that people are most familiar with overall, that's the one that I chose just to give as basically as an illustration here. So you look at carbon-12, 13, and 14. What do they have in common here? Same number of protons, same number of electrons, but different number of neutrons. And that's the definition of an isotope. Same number of protons, but a different number of neutrons. Now, when you have an isotope, basically, the different ratios of these radioactive elements in here, they degrade or they decay at a set rate. Now, this radioactive decay, as it's called, is something that is measurable by scientists. So they can take a radioactive substance and by the ratio of parent particles versus daughter particles, which are the ones that things decay into, they can tell how much time has lapsed. So then if you go back to sort of towards the beginning where we found that zircons are in like all the major rock types as well as a lot of meteorites, well, that gets in really, really handy as it turns out. So this Australian sandstone right here has zircons over 4.4 billion years old. Now the Earth is not that much older than that. And because zircons contain trace amounts of radioactive elements, now this again, small amount, not really dangerous to you, but still, now because they contain amounts of these radioactive elements, they're often used in what's called uranium-lead dating, where uranium decays into lead. Now, with one of these two methods of dating has a half-life of 710 million years, and the other one has a half-life of 4.47 billion years. So zircons, if they're found in certain bodies of rocks, they can be very useful for dating rocks that are extremely, extremely old, and then thusly they give us an idea of everything from, say, a little bit of the environment of past ages to a lot of other things. So they give you an idea of really the time in which these rocks were formed and become geologic clocks. Now, that's a little bit on our marvelous friends, the zircons. Thank you very much, and have an absolutely wonderful